So let's talk a little bit about Beam before we dive into what Beam and Pulsar have to do with each other. So in Mateo's talk, there was this innocent-looking little box that said analytics services on it, which, very innocent, small little white box, looks great. That's where we live. Under that little box, there's usually, these days, a fairly extensive data processing pipeline, or in almost all cases, pipelines that a company needs to maintain. And one of the ways you can do that, and we think a pretty good way, is with Apache Beam. So what Beam is sort of an abstraction on the parallel data processing pipeline concept. In the beginning, there was Hadoop, and before that, MapReduce at Google, and things like that. And what Beam tries to do is actually bring that up another layer and provide a level of abstraction that allows us to unify the traditional sort of batch jobs that exist, as well as streaming jobs. So by doing things like providing watermarks and checkpointing and things like that, we can start to talk about streaming models in the same way we talk about batch models. And we do that at sort of a conceptual level. So Beam provides a literal model, right? One that's computer representable that you can then implement and manipulate inside your platform of choice. And that lets us do a few different things. So the first thing it lets us do is it allows us to be multi-language. So we can provide APIs and SDKs for a variety of different languages that are idiomatic to that language. So today we have in GA for Google Cloud, we have Java, Python, Go. There's a Scala one as well that someone else provides, but we also have other experimental ones like there's a TypeScript SDK. So if you want to write pipelines in JavaScript like that old Microsoft Hadoop project, you can do that. It's TypeScript, so you get classes and schemas and stuff like that, so it's a little nicer, but if that's your thing, that's what you can do. It also allows us to run on lots of different underlying platforms. So obviously there's Cloud Data Flow, where Beam is sort of the native language, but it also means we can provide integration with things like Flink and Spark as the underlying substrate to execute. So you don't have to go out and get a new type of cluster, figure out how to install that, and run it. You can run it on your cluster. We also provide for mostly development purposes, but it also allows us to provide things like direct runners, which run on your local box, and even a sandbox you can use from the Beam website if you want. So you can play around with it on the web without having to install anything. So that's kind of fun. And then the last thing it does is it also means that as we're unifying, we need to think about our sources and sinks, right? Because that's really, you can define all the pipelines you want. If you can't get data in and out, not so useful. And so Beam also, unlike a lot of other platforms, really cares about what we call IOs, which is our, sort of our pantheon of sources and sinks. And we have lots of different ones, and we actually ship them with Beam as an open source project. And that's, kind of what we're talking about here today. So for example, just to use a very simple example of what using Beam might look like, on the left you have your, this is a very simple transform, right? It's just doing a group by and then summing. You can do that in SQL if you want. That is actually an option. You can do it in Python, and it kind of looks Python-y with a little pipe operator, very, very modern. You can do that in Go. Where you'll notice that you can just call sum directly in an idiomatic way. And then, of course, Java, as is tradition, you have a lot more typing. And that sum per key is something that we call a p-transform. That's one of the two primary constructs within the Beam SDK, p-transforms, which describe how to change data from one format to another format, or to fan out or fan in. But also p-collections, which represent sort of arbitrary parallel collections of entities with known semantics, such as ordering and things like that. You can implement those in the language of your choice. There are also a bunch of built-in ones for you to use. And then when you go to run it, as I said, you can run that pretty much anywhere you want. You can run that on Dataflow. You can run it on Flink, Spark, Samza, and we actually have, in the Python community, there's a couple of new ones who are just coming online, Ray and Dask. which are parallel processing frameworks and environments for primarily focused on the Python community. And you can run them all there. So, we think this is a differentiator for Beam relative to a lot of other projects, right? Like we have that unified model. It lets us do some interesting things. It also lets us do some interesting optimizations depending on the environment that we're running in. It allows us to support lots of different languages. You can use what you want as opposed to being forced into a specific language. And even mix and match. We have some environments where you have part of your pipeline implemented in one language, part of it implemented in another. That comes up a lot in like ML applications, for example, right? You're using something like SciPy or NumPy or Sci or something like that. It's written in Python. You should be able to hang out in Python. You don't want to have to port that to Java to be able to run it or something like that. We have the portability across different things. So you can run where you are. You can run on-prem. You can run in AWS. You can run on Google Cloud in a couple of different ways, actually. Or you can even run on your local box or in the web. And then finally, why we're here at the Pulsar Summit is we actually care a lot about IOs, right? It's really, for the folks who work on Beam like myself, it's actually kind of the thing we think a lot about because, without good input-output systems, you're going to be fundamentally limited. So we spend a lot of time thinking about how can we make our IOs perform well across the entire community, not just, the few that might be relevant to Google Cloud because we can run anywhere. So we want good IOs for files, for databases, and for messaging systems like PubSub and like Pulsar. So about a year ago, I want to say. I'm actually relatively new to the team. I'm still the new guy. I've been a long-time user of tools like Beam and its predecessors, and I finally got to put my money where my mouth is after complaining about them for a couple of decades. So for Pulsar, about a year ago, the team was looking around and noticed that Pulsar was starting to get a lot of traction in the community. Beam is an Apache project and something that integrates so much with IOs. We really like to interact with the community because we depend a lot on the community to provide that underlying data storage that we abstract away. And so we contracted with a vendor to start providing the first of the Pulsar IOs for us. So in September, we got the very first initial pull request for the Pulsar IO from that contract organization to implement what's called a splittable do fund. So in the Beam world, like I said, there's really only two underlying constructs. There's the p-transform, which describes a transformation, as well as the p-collection. And any sort of IO, such as Pulsar or anything like that, is a form of p-transform, right? It's not a special thing on the side for doing IO as you typically see. It's itself a transform. In this case, it's a transform of some other format into the Beam world. This lets us do some interesting things as well with transforms. So for example, because they're transforms, you can have an IO that's fed from another IO. So for example, you want to process a lot of files. When you get enough files, it turns out that itself is a data processing pipeline, right? If you have billions of files you need to process, you're not going to just linearly read those, right? You want to do that in more than one thread. And so you could have an IO that's actually driving a file IO of splitting out, okay, these are the files I actually need to look for, where are they, and then reading them in. So the Pulsar IO is of that form, and it's using something called a splittable do fund, which is a sort of advanced version of a pre-transform that lets you take a block of elements and split them out and start to parallelize them where they ordinarily wouldn't be parallelizable. Kind of the analog is, remember in the old days with Hadoop, if you had like a gzipped file in your HDFS cluster, you only could read only one reader could actually work with that, so your parallelism was limited by the number of files you have. And then we moved towards file formats that could actually be split. modern versions are things like Parquet inside of Google. You got Capacitor. There's a bunch of different formats that could do this, right? So the splittable do fund is kind of the next level of abstraction of that is like, well, in a streaming world, you don't have necessarily a file, or in this more general world, you don't necessarily have a file, but you do have things that you might know how to split. So for example, like a topic, you know how to start to shard that out to different machines, even if the input is not necessarily sharded itself. So the Pulsar I/O is an example of one of those systems where even though the input might have one type of sharding, it can actually reshard when it goes into processing. So we got the first initial pull request about a year ago, and the first design doc, which I wasn't on the team yet. It seems like maybe the order could have been a little different, but the first design doc for the connector in January of this year. And then the final implementation that was actually merged into the project and is now part of Apache Beam and the releases in March. So that would have been somewhere in the 2.30 series. We're about to do 2.41, and so you can find it there. And then the first pull request from Stream Native, thank you for inviting us, was actually submitted in June of this year. So we're making good progress on getting good, solid Pulsar I/O support into Beam to use as a primary source of data, and sync as well. Right, all I/Os can go both directions. So now Pulsar is part of Beam. You can use it. Please give it a shot. Try it out. Like I say, you can do this on your own dev machine or on your existing infrastructure. So like I say, you don't need, if you already have an existing system, something that runs Spark, something that runs Flink, those are the two primary on-prem systems that people use. Like I say, there are a couple others like Samza you can use if you like. There might even actually be a Yarn runner, but I don't know that that's part of the primary one. Or if you're a Google Cloud customer, you can, of course, just use Dataflow. So what's next? As we start to continue to support Pulsar I/O, like this is a lot of what my team does, is work on I/Os and help make sure that they're high quality and work with other folks. Stream Native is ensuring that the Apache Beam Pulsar I/O will be a certified Stream Native cloud compute engine connector so that we can integrate very closely and get really good support in all of our systems for working with Pulsar. And I went very, very quickly, so I'm not sure what to do next. Yeah, thank you. And if you want to reach out on the PM side, Sachin, who couldn't make it today, is probably your best point of contact. You can email me, but it will probably get lost, and I probably won't be able to answer your question about Google Cloud because I'm on the engineering side. So if you have engineering questions, I'm happy to talk about those. But sort of the more business side, feel free to reach out to Sachin.